Okay, hey, how y'all doing? So we're going to talk a little bit about how changing the way we look at and document what our termination of peak expiratory flow is on our patients in aprv. Okay, so we had a little meeting with Keith Kerr, myself, and Dr. Habashi over some aprv techniques and things we were seeing and things we weren't seeing. And some of the important information that came out is that we have been possibly including flow that is produced by the circuit recoil on our patients, incorporating that into our total percentages of what our trap percents are. And so first of all, we're gonna stop doing that. We're gonna look at this and we're gonna start documenting what the true lung flow terminations as a percentage are. And how we're gonna get this is, how we're gonna look at this information is our waveform is depicted here. And what we're looking for as our actual peak expiratory flow rate in aprv is what we're looking for is the flow to actually start to decelerate. And at that point where the flow starts to decelerate, Dr. Habashi thinks that that is where the true patient's lung flow becomes realized. So in this example, this drawing, the green line, it would be your peak expiratory flow as measured by the vent. And how we used to do it is we would come to this peak expiratory flow with our cursor and we would see that it was 150 liters per minute. And then we would wait for it to slow down, and where it becomes, the red line becomes the black line. At that point, we would measure that speed and we divide those out, and that's how we would get our termination of peak expiratory flow. And on this representation, it looks somewhere to be about 50%. Well, what he's saying is the green line, until the flow starts to actually slow down, you're looking at recoil speed or recoil flow from the circuit recoiling back when the pressure is released. And that's not true lung speed or lung flow. So that should be removed from the percentage. So in our new platform, what we're going to do is we're going to follow the green line up to where it becomes the red line. And the red line, the first part of the red line is where the green kind of slows down to a little bit. And what he's saying is at that point, now we're truly seeing lung flow or lung speed, if you will, from the patient's lung. And from that point should be where we document our peak expiratory flow measurement, which in this case, it would be 100 liters per minute. And then continue on to where it becomes the black line on expiration, as we have done in the past, which that now would be 80 liters per minute, and divide those out. And now this patient's true termination of peak expiratory flow is somewhere around the range of 80% instead of 50% as we think it could be by just looking at by our old way. So from now on, what we're going to do is we're going to target our peak expiratory flow at the point where the flow first starts to slow down, and use that as our peak expiratory flow measurement. And then we're going to continue as we always have, finding our end expiratory flow and dividing it out to get to our termination of peak expiratory flow. So hopefully this will make our trap percentages much on plane with how they used to be or how they are at other facilities, so that we can get closer to our what we think to be is our 75% trap percent, that what we think most patients should be sitting at. Okay, if you have any questions, don't understand this, let me know. You got my text messages at the bottom of my emails, or email me if you need any more clarification. Thanks.